Factoring polynomials undoes polynomial multiplication. There are many reasons we want to factor. They're kind of the building blocks of polynomials, the factors that we find. Just like prime factorization finds the prime numbers that build up certain numbers. Factoring polynomials lets us find properties of functions that are polynomial in form. There's many other reasons why we do it. Those are just some examples. There's also a lot of tricks for doing it. I have laid out 4 kind of steps that you can follow, but you'll have to just do it by hand and get used to understanding how to do it for yourself. First off, monomials do not factor. Those are pretty much just a term that's by itself, and there's really no way to factor that down. So keep that in mind. Always the first step is to take out the greatest common factor. That's because whenever we do that, our problems typically get smaller and easier to work with. So take out the GCF as the first step whenever possible. In this case, we can take out a 4 from all of these terms. So take out a 4, we get 3t to the 5th minus 5t to the 4th plus t cubed plus 2t squared minus 4. You see that I divided every single coefficient by 4. That's how we factor out the GCF. There's no way to continue factoring this problem. You can see if you follow along with what I'm saying and go back and at the end, this really can't be factored any further using the strategies that we have. That's always the first thing. Factor out the GCF. Next, if we have a binomial, we can use these 4 formulas to factor them down. This is the first one here. I is a difference of 2 squares. This is a sum of 2 squares, a sum of 2 cubes, and a difference of 2 cubes. And here I have some problems to try these out. So this first one here, x squared plus 16. This is the same thing as x squared plus 4 squared. And you can see that if we let a equals x and b equals 4, it satisfies that formula. Therefore, it is prime. And prime just means that with the strategies that we have right now, we cannot factor this down further. This can factor, it uses complex numbers, but we're not going to use those at this moment in this video. That one is prime, meaning it cannot go any further. Right. The next one is very similar here, number 2. Here we have x squared minus 4 squared. And now you see this one satisfies this when a equals x and b equals 4. So we have a plus b and a minus b. This thing factors down to x plus 4 and x minus 4. And that is completely factored. You can always ask the question, does this factor any further? And you should always ask that question. And you can always know that it doesn't factor any further whenever the powers on the variables are less than 2. In this case, we have x to the power of 1, and of course 4 is x to the power of 0. There's no x there. So we know that these are what are called linear terms. So let's look at this next one here. Number 3. Let me do it in black. This one, we can ask the question, what is the GCF? We should always ask the question. In the first 2, I didn't because there was no GCF. If there was, I would have taken it out though. Number 3, we can ask, is there a greatest common factor? And there is. Y can be taken out of these 2 things. And this is what we're left with. Now we look on the inside of the parentheses and ask, can this factor any further? The answer is yes. In fact, I can rewrite this. 64 is the same thing as 4 cubed. So 64y cubed is the same thing as 4y cubed. And 1 can always be written as 1 squared or 1 cubed or 1 to the 4th, whatever you need. So 1 is the same thing as 1 cubed. Therefore, this thing fits this third formula. And here we're going to have a equals 4y and b equals 1. Now we can use this formula. This y that's out in front here, that's just going to stay out in front. And then we have a plus b times the quantity a squared, which is 4y squared, minus ab plus b squared. And simplifying, 4y squared is 4y times 4y, or 16y squared. This, of course, becomes 4y, and 1 squared is 1. And this cannot be factored any further. You could ask the question, can this quadratic be factored any further? And it cannot. The a cubed plus b cubed and the a cubed minus b cubed. If you could factor it, it would show it in those formulas, but you cannot. So there's really no point in continuing any further in that. So that is the factored form of 64y to the 4th power plus y. All right. If you have a trinomial, this is where we use the classic AC method or guess and check. So I'm going to use the AC method to show this. I think it's the most, it provides a structure on how to do it. The guess and check method, you can try it. If you know how to do it well, then it's faster than the AC method. But if you're not really sure what to do, then the AC method is your go-to method. Now I'm not using the quadratic formula in this video. Quadratic formula will always find what you want, but it requires a bit of work and making sure you understand what you're doing with the numbers that you get. I'm just going to show you the AC method to factoring this thing. First off, this polynomial is not in standard form, so I'm going to rewrite this as 8x squared minus 28x minus 16. Highest power of x to the lowest power of x. And now we can kind of compare this thing to the classic ax squared plus bx plus c. So you see that a equals 8, b equals negative 28, and c equals 16. Negative 16, I should say. Why do we do this? Because we're going to use the AC method, which uses a, b, and c in regards to this x here. On top goes a times c. A is 8, c is negative 16. A times negative 16 is negative 128. Then b is negative 28. Actually, I've done this wrong, because you should always ask the question, what is the greatest common factor? And if I do that, you're going to see these numbers are actually going to get smaller. So let's take out the GCF first and then come back to this AC method. I can take out a 4 from all of these terms. Give me 4x squared minus 7x minus 4. Oops, I did that wrong. It's 2x squared in the front. 2 times 4 is 8. And now you can see that a, b, and c change to smaller numbers. A is going to be 2 because of this number in front of the x squared term. B is negative 7. That goes right there. And c is negative 4. which is the last term by itself. You don't really ever include the variables in this. Yeah, I guess you could, but it makes it a little bit more confusing. Now a times c becomes 2 times -4, which is -8, and b becomes -7. And these numbers are a lot smaller, which is going to make this a lot easier to work with. That's the importance of taking out the GCF, that the numbers become a lot easier to work with. Now what we're looking for is two numbers that goes here and here that multiply to give the top and add to give the bottom. So multiply to get -8, add to get -7. If you're not sure where to go, you can guess and check. This is actually pretty easy to guess and check for these two numbers. If you're not sure what to do, you can always write out multiples of -8. 1 times -8. 2 times -4. 4 times -2. And 8 times -1. Those are all the possible combinations that multiply to give -8. Then we add going across. 1 plus -8 is -7. 2 plus -4 is -2. Then we get 2. Then we get 7. And we're looking for two numbers that multiply to give -8 and add to give -7. And you see the first one is what gives us it. You may also notice that if we just flip the signs here, we get the opposite sign there. So if you're looking through the numbers and you see that you actually do get the right addition but the wrong sign, just flip the signs of the numbers, and that'll get you there. But since we want -7, we're going to use 1 and -8. You can check 1 times -8 is -8, and 1 minus 8 is -7. So that's correct. Now we can do the rest of the AC method. This is how it goes. The 4 just stays out in front. Just make sure you leave it there. Then you bring down the first number. Let's say 2x squared. Then we split this number up into two numbers. The first is going to be this 1, so we get plus 1x. The second is going to be this -8, minus 8x. Then we bring down the last number and close it off. So all I've done is I've rewritten this polynomial, this quadratic here inside the parentheses, in a special way with special numbers, so that my next step is going to be quite a useful step. I'm going to factor by grouping. That's the next step here. In other words, I look at the first two terms and I ask, what can I take out? The 4 is still out in front. Let's leave it out there. I can take out an x from those. So I'm going to take out an x. And what does that leave me with? That leaves me with 2x plus 1. Then I look at the next two terms in orange here. -8 minus 4. I can take out a -2. Nope, -4 is the biggest thing I can take out. Always make sure you take out the biggest thing. That gives us 2x plus 1. And you'll see that these parts here are the exact same. And that's what we want. We want the exact same thing there. Write that down. And then write down what's on the outside of it, the green and the orange. X minus 4. And this is completely factored. The AC method it's just a process that uses different techniques to breaking down this thing into easier chunks. The last half here that I did from this portion on, this is called factoring by grouping. Very helpful technique, which we'll see later on. But the first part of the AC method is finding those special numbers. Once you find those special numbers, factoring by grouping is a little bit more straightforward. But this whole portion here, that can take the longest and be the hardest work to do. But if your numbers are small, like I did when I took out the GCF, it's actually a lot faster. Okay, if you don't have a trinomial or anything smaller than that, we can always just try factoring by grouping. If we have more than 4 terms, 5 or more terms, there really isn't any other strategies we can do besides taking out the GCF and then calling that good. You have to use other techniques which are beyond the scope of this video. But with 4 terms, we can ask the question, does this factor by grouping? So we'll look at the first 2 terms, and we can take out a q from those. That leaves us with p squared minus 25. The next 2 terms, we can take out a positive 3. It leaves us with p squared minus 25, which the black is the same now. So we can take that out. And on the outside, we have q plus 3. Now, we're not done here because we can factor down further this p squared minus 25. P squared minus 25, if p equals a, I should do it the other way around here. If a equals p and b equals 5, because 5 squared is 25, now we have a difference of 2 squares. And that's going to be a plus b times a minus b. And then of course the q plus 3 is still involved. And these are all linear terms, so we know that is completely factored. Always make sure you take out the greatest common factor in the beginning, and always make sure you ask when you get close to the end of the problem, what you think might be the end of the problem. Ask, can I factor this further? Here we have a polynomial, and we could try to expand it and multiply out x minus y squared. But what you'll notice is that if we say a equals 3 and b equals x minus y, then this thing becomes a squared, 3 times 3 is 9, minus b squared. And this is a difference of 2 squares. So we actually don't need to do anything else, any kind of expanding, because this thing immediately factors down into a plus b times a minus b. And we can do some simplification. Can distribute this negative into there, giving us minus x plus y. And there is our factored polynomial. You can see that x and y both have powers less than 2, so there's really no need to check to see if we need to factor this any further. All right, for this one, we have a power of 6. Now this is interesting because 64, we can rewrite 64 as 2 to the power of 6. Now where do we go? Well, we're trying to look for, this is a binomial, right? So we're going to look for either a difference of 2 squares, because there's a subtraction sign there, or a difference of 2 cubes. The interesting thing about this problem is that we can get either one. If I said t cubed squared minus 2 cubed squared, that gives me a difference of 2 squares. I can also say t squared cubed minus 2 squared cubed. That gives me a difference of 2 cubes. Which one should you do? Well, you can do either one. You should get the same answer either way, as long as you're doing the work correctly. I would probably tend to go towards the difference of 2 squares. I think that's a little bit easier to work with. So a difference of 2 squares. This is going to be a plus b times a minus b. We have t cubed plus 2 cubed times t cubed minus 2 cubed. I'm leaving it as cubed rather than saying 2 cubed equals 8. 2 times 2 times 2 equals 8. I'm leaving it as cubed because now I can use the difference in sums of cubes. So the first one gives me, just use the formula, t plus 2 times t squared, it's going to be minus 2t plus 2 squared, which is 4. Then we have t minus 2, t squared, plus 2t plus 4. And that would be completely factored. Now, going the other way, this gives us t squared minus 2 squared, giving us, let's see, t to the 4th plus 2 squared t squared plus 2 to the 4th, and likewise t squared plus 2 squared. Oh, sorry, no, there's nothing else there. That's a difference of 2 cubes. And now we have to think about factoring this down further. And we can do it. This is a difference of 2 squares, which will actually become that term and that term. And this here, we can use this second part here, the green here. This is going to be a polynomial, and it will factor down into this one and this one, but it's going to be a lot more work. So if you ever have a choice like this, which you probably won't really ever come across this problem very much, if you ever have a choice like that, I recommend doing it the first way here. Don't do it the second way. Just make it into a difference of 2 squares first. That's quite a nice simplification. A plus b, a minus b, and then break it down further. All right, here is a trinomial. So we can ask, is there a greatest common factor? And there isn't here. Check that for yourself. It's not a binomial, so we don't have to do that. It's a trinomial, so we need to look at the AC method. Now, these numbers are quite large, so it's going to be a little bit more work with the AC method, but we'll be able to do it here. So for the AC method, we have ax squared plus bx plus c. It's fine if x and y are the different variables. That doesn't really matter. What matters is the positions of the coefficients. So in other words, a is 16, b is 56, and c is 49. So a times c on top, 16 times 49, 784, and b on bottom gives 56. So we need two numbers that multiply to give 784, but add to give 56. So these numbers are quite large. You can write out the table that I showed before, right? 1 times 784. If you add it going across, gives us 785. 2 times, let's see, 2 times 392. Add going across gives us 394. Now we're getting closer to 56, but it's still quite a ways off. So it might help to jump down a bit. We can go up to, like, 16 can go into there. 784 divided by 16 equals 49. We're not looking to get any decimal numbers, only whole numbers. And when we add going across, that gives us, let's see, 55, 65. Now that's very close, but it's not quite there yet. We need to keep going down further. What you can do is you can keep taking 784 divided by 17, divided by 18, divided by 19, and keep going until you find a number that doesn't give you a decimal. And I think the next one you'll find is 28. And it's actually going to be 28 times 28. And this does in fact give us 56. So that's what we're looking for. Sometimes these large number problems take a while to find the numbers that you're looking for. But now that we have it, we can continue with the AC method. Let me just write this down a little bit further and show you the method again. Bring down the first term. Split up this middle term into two numbers that we found. The first is plus 28. And we always add the central variable, which is just y. Then we have plus 28 y. Finally, bring down the last term, giving us 49. Now we can factor by grouping. What can I take out of the first two terms? I can take out a 4y, leaving us with, I should write that in blue. That's what I'm taking out. Leaves us with 4y plus 7. What can I take out of the next two terms? I can take out a positive 7. And that leaves us with a 4y plus 7. And you see the black terms, the black quantities are the same. That's what we want. 4y plus 7. And then on the outside, I'll write it like this. 4y plus 7. And you see we get the exact same terms for this because these numbers here were the exact same. That's typically how it happens. You'll get 4y plus 7 squared in this case. All right, this is the last problem. This one's a little bit different because we have a power of 4. And we really can only use the AC method because this is a trinomial, so we have to use the AC method. We can really only use that on quadratics, which is the highest power is 2, the next highest is 1, and the last is 0. That's what I was showing you with the ax squared plus bx plus c. That's a quadratic thing. So we need to make this into a quadratic if possible. And we can do that by saying y equals x squared. When we do that, y squared equals x to the 4th. And this whole thing now becomes y squared minus 3y minus 4. And this is a quadratic. It's just in a different kinds of variables. So we have to make sure in the end we revert back. But we can continue with the AC method using this new quadratic. So we have a times c. A is going to be 1 here. C is negative 4. And b is negative 3. So two numbers that multiply to give negative 4 and add to give negative 3. With small numbers like this, there's really no need to create a table. You can probably just think about them in your head. This is going to be what we can do. We know 4 times 1 gives us positive 4. We can do negative 4 times 1 gives us negative 4. And when we add them together, we get negative 3. So that's correct. So we'll do the AC method. Just kind of writing out these things all in one go. We have y squared. I'm not going to bother writing the 1. There's no need. And the first number we got was negative 4 with the variable. Then we got plus 1 with the variable. And bringing on the last term gives us negative 4. Now we can factor by grouping. We can take out a y there, giving us y minus 4. And out of the next two, we can take out a plus 1, giving us y minus 4. So this factored form is going to be y minus 4, y plus 1. Now, of course, we're not done here because we changed the variable into y, but the problem gave us a variable in x. So all we need to do is take this definition we made in the beginning and plug it back in. That gives us x squared minus 4, x squared plus 1. And now, maybe you noticed this, we can factor further. The first term, the first factor there, the x squared minus 4, this is a difference of two squares, namely x and 2. X times x is x squared, and 2 times 2 is 4. So we get x plus 2, x minus 2. That's what this thing breaks down into. This last thing here, this is a sum of two squares, and that was prime, meaning it cannot factor. So we just write it the way it is. There's no need to try and factor it at all. It's prime. And there we go.